Good day everyone. We are here to present a lesson about finding the six trigonometric functions: sine, cosine, tangent, cosecant, secant, and cotangent for the special angles 45 degrees, 60 degrees, and 90 degrees. Before we start, let's first recall what trigonometry is. Trigonometry is a branch of mathematics that studies the relationships between the sides and angles of a triangle. It's one of the most useful tools in geometry, physics, and even real-life applications like engineering, navigation, and architecture. The six trigonometric functions are based on the ratios of a right triangle's sides. They are defined as sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent, cosecant equals hypotenuse over opposite, secant equals hypotenuse over adjacent, and cotangent equals adjacent over opposite. Each of these tells us something different about the relationship between the sides and angles. In this presentation, we will focus on the special right triangles, the 45-45-90 and the 30-60-90 triangles, because their side ratios never change. Using these triangles, we can easily find the trigonometric values of 45 degrees, 60 degrees, and 90 degrees. Now, let's start with the 45-degree angle, to be explained by David Makapundag. Now that we've discussed all three special angles, let's wrap it up. For 45 degrees, 60 degrees, and 90 degrees, we use the special right triangles to find their trigonometric functions. These angles are important because their trigonometric values are exact. These values help us solve problems in trigonometry, geometry, and even real-world situations like finding heights, distances, and angles of elevation. Thank you for listening. We hope our presentation helped you understand how to find the six trigonometric functions of 45 degrees, 60 degrees, and 90 degrees.
Let's begin with the 45-degree angle. We use a 45-45-90 triangle for this case. This triangle is special because it is an isosceles right triangle, meaning it has two equal sides and one right angle. Let's assume both lengths are equal to 1. Find the hypotenuse. We can use the Pythagorean theorem. A squared plus b squared equals c squared. Substitute the values. So equals to 1 squared plus 1 squared equals c squared, which means 2 equals c squared. So c squared is equal to square root of 2. So the sides are 1, 1, and square root of 2. Now we can solve for the six trigonometric functions of 45 degrees. Sine 45 is equal to opposite over hypotenuse and equal to 1 over square root of 2. So which means it's equal to square root of 2 over 2. Cosine 45 degrees equal to adjacent equal over hypotenuse, which is equal to 1 over square root of 2, which just means square root of 2 over 2. Tangent 45 degrees is equal to opposite over adjacent, which is really simple. It's equal to 1 over 1, which means it's equal to 1. Cosecant 45 degrees is equal to 1 over sine, which just means it's equal to square root of 2. And same for the secant 45 degrees, because it's just 1 over cosecant, or cosine rather. Cotangent 45 degrees is equal to 1 over tangent, which is equal to 1. What's interesting here is that sine and cosine are equal for 45 degrees. This is because both legs are the same, meaning the triangle is perfectly balanced. In real life terms, angles of 45 degrees appear in many designs, like the diagonal of a square, ramps, Android roofs, When you tilt something halfway between a horizontal and vertical, that's a 45 degrees angle. So to summarize, for 45 degrees, sine is equal to cosine equal to square root of 2 over 2. Tangent is equal to cotangent equal to 1. Cosecant and secant is equal to square root of 2. Now that we understand this pattern, let's move on to the next special angle, the 60 degrees, which will be explained by Paul.
Thank you. Now let's analyze the 90 degrees angle. In a right triangle, a 90 degrees angle is the largest possible angle when we reach 90 degrees. The triangle becomes a straight up vertical line from the x-axis to the y-axis. Let's recall the trigonometric definition using the unit circle, where the hypotenuse or radius is 1. At 90 degrees, the x-coordinate will be 0 and the y-coordinate will be 1. So the sin will be 90 degrees equals y over 1 equals 1. And the cos will be 90 degrees equals x over 1 equals 0. In the tan 90 degrees equals sin or cosine, and the tan 90 degrees equals sin over cos equals 1 over 0. Undefined because division by 0 is not possible. CSC or cosecant 90 degrees equals 1 over sin 90 degrees equals 1 over 1 equals 1. While sec 90 degrees equals 1 over cos equals 90 degrees equals 1 over 0, undefined. Cot 90 degrees equals 1 over tan 90 degrees equals 0. This shows that as the angles increase towards 90 degrees, this shows that as the angle increases toward 90 degrees, the sin function approaches 1, while cosine approaches 0. In real life, 90 degrees is what we call a right angle. It's everywhere. It's the angle between the walls in the floor, the page of a book, in the corners of a square. So the 6 trigonometric values for 90 degrees are sin 90 degrees over 1, cos 90 degrees over 0, tan 90 degrees equals undefined. CSC or cosecant 90 degrees equals 1. Sec or 90 degrees equals undefined. Cot 90 degrees equals 0.
Thank you, David. Now, let's talk about the 60 degrees angle using the 30, 60, and 90 degrees triangle. This triangle has a fixed side ratio of 1 square root of 3 and 2. Here's what that means. The side opposite 30 degrees is the shortest side. The side opposite 60 degrees is 3 times longer. The hypotenuse is the longest side and equals 2 times to the shortest side. Let's assign the sides. Opposite 60 degrees equals square root of 3. Adjacent to 60 degrees equals to 1. Hypotenuse equals to 2. Now, we'll find the 6 trigonometric functions for 60 degrees. Sine 60 degrees equals opposite over hypotenuse equals square root of 3 over 2. Cosine 60 degrees equals adjacent over hypotenuse equals 1 over 2. Tangent 60 degrees equals opposite over adjacent equals square root of 3 over 1 or square root of 3. Cosecant 60 degrees equals 2 square root of 3 over 3. Secant 60 degrees equals to 2. Cotangent 60 degrees equals square root of 3 over 3. We can see that sine and cosine switch patterns from 30 degrees to 60 degrees. For example, sine 30 degrees equals 1 half, while sine 60 degrees equals square root of 3 over 2. If you think about the equilateral triangle cutting in half forms a 30, 60, and 90 degrees triangle, that's why 60 degrees is a very common and natural angle in geometry. It comes from equilateral shape. In real life, angles of 60 degrees can be seen in hexagons, triangular road signs, or even bees, honeycombs, natural labs 60 degrees. So to summarize, sine 60 degrees equals square root of 3 over 2. Cosine 60 degrees equals 1 over 2. Tangent 60 degrees equals square root of 3. Cosecant 60 degrees equals 2 square root of 3 over 3. Secant 60 degrees equals to 2. And cotangent 60 degrees is equals the square root of 3 over 3. Now that we've solved for 60 degrees, let's move on Jason Coron.